Now we have just completed simple harmonic motion and we are moving towards the wave motion. What is wave motion? Consider a pool of water in which we are dropping pebbles. What will happen? Ripples will get created. These ripples have specific pattern. They'll increase in their circumference with a particular interval of time and they follow a particular wave pattern. These are called waves. So wave is just a transfer of energy. What happens during wave formation? Particles never transfer from one point to another. It's only the energy which gets transferred from one point to another. It's like this. We hold a straight rope and we give it a jerk from one end. It will cause wave to form. So this is called velocity of wave, this is just an explanation what is velocity of wave and velocity of particle. Here the particles are undergoing sinusoidal motion, right, in the form of crust and trough. So that itself is the velocity of particle, whereas wave velocity is the velocity with which the whole wave is traveling. Clear? So example, we have hold a rope and we have given it a wave motion from one end. What will happen? The rope is going to go sinusoidal motion such that you can now differentiate that the velocity with which the rope particle is going is called velocity of rope particle or the velocity of particle, whereas the velocity with which the whole wave is going forth is called the wave velocity. Okay, so wave travels along its medium, but the individual particles just move up and down. They do not move further, they just transfer their energy from one to another, because every medium is elastic in nature. So due to the property of elasticity, the energy gets transferred. Now all type of traveling waves transport energy. For example, the same rope thing, the rope was held, it was given a jerk and the energy gets transferred. So every time particle will have definite set of energies in each direction. Okay, so continuous waves start with vibrations too. If the vibration is simple harmonic motion, then the wave will be continuous in nature. Okay, now what are the characteristics of wave? I have drawn a wave. First of all, the maximum displacement is the amplitude. The distance between two consecutive crusts or two consecutive troughs is called wavelength. The time to cover one complete wave is called time period, and reciprocal of time period is frequency. Lastly, the velocity is frequency times wavelength. So frequency into wavelength is the wave velocity. These are four important aspects of any wave motion. Same example. Now there are type of waves, two type of waves, one is longitudinal and one is transversal. So transverse and longitudinal, what are transverse waves? The waves which travel in the form of sinusoidal. That means the direction of propagation of particles are going up and down is perpendicular to the direction of propagation of wave, because wave is going in forward direction whereas particles are going in vertically upwards and downward direction. See this one, particle is going vertically upward and downward direction, whereas the wave is going forward direction. Now this type of waves is called transverse wave, whereas in longitudinal wave there are compressions and expansions, compressions and rarefactions. So compression means the particle will come closer and then they will go farther. This type of compression and rarefaction in terms of, again due to the elastic nature of the medium, is called, this type of motion is called what? The longitudinal motion. Okay, now here the direction of motion of particle is parallel to the direction of propagation of wave, where in that case transverseness it was perpendicular to. Okay, sound waves are longitudinal in nature. For example, when this is drum from which beats are producing, the particles are what? They are getting very closer and then they are moving farther away, then closer, farther away. So this is how they are moving in terms of compressions and expansions. Earthquake, this is general information that earthquake produce both type of waves. Earthquake produce longitudinal and transverse wave. Both can travel through solid material, both, but only longitudinal wave can propagate through a fluid. That means longitudinal wave cannot propagate through solids. Okay, so in transverse direction, a fluid has no restoring force. The surface waves are waves that travel along the boundary between two media. Okay, now energy transported by wave. Energy is defined as, definition first let's define the intensity. Intensity is energy per unit time per unit area. Energy upon time is power, so power upon area. So intensity is also proportional to square of the amplitude, because power is square of the amplitude, right? Now if a wave is able to send out three-dimensional structure or in 3 dimensions, then what will happen, that whole wave can be considered as a spherical wave or spherical wave front. Okay. By looking at the energy of a particle matter, the medium of the waves we find, the energy formula is 2 pi square P S V T F square A square. What are these terms? Rho is density, surface in which the wave is passing, velocity, time, frequency and amplitude. And for same density, this intensity is P power upon S, so we get this formula. Therefore, the intensity is proportional to square of amplitude. Okay. Now, reflection of transmission of wave. Reflection means when a wave gets or hits a surface, it gets reflected back. For example, see this figure. With respect to time, what is happening? It is fixed from this point. Wave is coming towards this point, and at one point it gets reflected, so it is going back. Now, got it? It is coming, this hook is fixed, so wave is going back. This is called reflection. A wave hitting an obstacle will be reflected and its reflection will be inverted. Water light section and heavy section. A wave encountering a denser medium will be partly reflected and partly transmitted. If the wave speed is less than the denser medium, the wavelength will be shorter. So, lighter section, this wave is coming towards a heavier section, that means there is a change in density, that means the wave is going from rarer to denser medium. Now, this wave is going to partially transmit and partially reflect. So, it got partially transmitted and partially reflected back. Okay. Now, 2 or 3 dimensional waves are represented by wave fronts. The wave fronts are, suppose these are those crust and trough formations. So, combine all the crust, we have got first wavefront, all the troughs, second wavefront, all the crust, third wavefront. This is how we represent wavefront. So, wavefront is what? Wavefront is locus of all the points which are at same energy or same disturbance. Law of reflection is always followed by rays or waves, that is, the angle of incidence will be equal to angle of reflection. That means, if a rope is like this, at whatever angle wave is coming and striking the hindrance, it is going to get reflected in the same angle. Then the superposition principle means what will happen if 2 or more waves will superimpose. The energy might get increased, it might get decreased, that is what superposition is called. So consider this example. In this one, 2 waves are coming towards each other and the resultant is a bigger, and after that this one goes there and this one goes here. In the next one, they were in same phase, that is why the amplitude got added up, whereas in this case they were in opposite phase, so amplitude got completely disturbed, so we have got nothing. So this is called interference or superposition in same phase, superposition in opposite phase. Sometimes it is also called as constructive interference and destructive interference. Okay. These figures show the sum of 2 waves. They are constructively and they are added destructively and they are partially destructively. See, these 2 same waves, crust and crust, adding with trough and trough, giving you a resultant bigger one. Crust and trough, trough and crust, adding up, giving you nothing, because the energies are getting destroyed by each other. The last one, crust with semi-trough and semi-crust, we are getting something. So you will not get as big as this time, but you are going to get something because the waves are getting added not in same phase, but there was some phase difference. What are standing waves? Standing waves occur when both ends of a string are fixed. Initially we fixed only one end, now both the ends of a string are fixed. In that case, only waves which are motionless and at the end of the string can persist. That means motionless waves which are going to die out. These are nodes where the amplitude is always 0 and the antinodes where the amplitude varies from 0 to maximum. So we have got node and antinode. So consider this wave, so this is a wave motion only. At a point where node is forming, there is no amplitude, this is mean portion, and at the point where antinode is forming, this is maximum amplitude. So this is got 1, 2 and 3 different type of waves. Okay. So suppose there is a wave of length L, it has been plugged from here. So length, the wavelength is what? Twice of length, or the length is half of wavelength. In other case, this one wavelength is equal to length. In this case, length is equal to 3 by 2 of lambda, 3 by 2 of wavelength. This is how frequency of standing wave of particular string is formed. This is called resonant frequency. Resonant frequency means the ultimate sum frequency. Okay. This wavelength and frequency of standing wave, we have a formula for that. Wavelength is 2L upon n. N is the number of nodes forming up. and frequency is v upon lambda L. V is velocity or n times v upon 2L. So we have got formula for both. Finally, the summary of the chapter. We have studied about simple harmonic motion. We have studied about how the waves are formed. So I'll change the slides one by one, and you can keep a note. You can mark all the important points which will be helpful for your revision, because I'm pretty sure throughout this lecture you were making your notes. So side by side, just see if you haven't missed any point. Okay, this is the entire summary of the chapter. Thank you so much.